today we're going to be talking about relative or measures of relative position. So suppose you want to know where an observation stands in relation to other values in a data set. Test scores for the ACT and SAT are examples of relative position. So here's what I mean. When you get like a 30 on the ACT, that doesn't mean like you got like a 30%. That doesn't mean you got like 30 of the questions right. It's a measure of relative position. They take all of the students who took that test on the ACT and they find out where you scored in relation to those other students, and that's what your score really means. So the most common measure of relative position is percentiles, okay? So in data sets that do not contain significant amount of identical data, the 30th percentile is where about 30% of the values are below it and about 70% of the values are above it. So you guys are actually, you should be familiar with percentiles. Like when you took the state assessment, you got those like results in the mail or whatever, and it's like you scored in the 75th percentile. That means you scored higher than 75% of students and lower than 25% of the students. Does that make sense? Another really common area that you're going to see percentiles is one day if you choose to have children, you take them to the doctor and they like weigh them and they measure them and they have this like chart on the growth chart. And they say, okay, they don't say like your child's too fat or your child's too skinny. They say your child measures in this percentile. So when I had my baby Sloan, she was a really, really fat baby. And so I'm not kidding. I would take her in and they're like, she's in the 99th percentile. She weighs more than 99% of children at this age. Or then like, you know, as she gets bigger, it like levels out. And then I had my kiddo Maggie, and I take her in and they're like, she's in the 32nd percentile. So she's small compared to children to her age. So that's what percentiles are helpful for, to see how you compare to others. All right, now, finding the P's percentile. That sounds weird, but hear me out. There are two ways to find a percentile, okay? There is a way to do this on Excel, all right? And we will be talking about that, but something you really need to know is there are different formulas to find the percentile, all right? Excel uses a very different formula, and you will get different answers on Excel, all right? When you do your homework today on Hawks Learning, they will not accept the answer that Excel gives you. All right, they do not accept that formula. So today I'm going to teach you how to do it by hand. When you do your homework on Hawks, you have to like calculate everything by hand. You can still use Excel to help you organize and all of that stuff, but you're going to have to calculate it by hand. Then in the future, everything past today, you can use the Excel function. Does that make sense? I'm okay with the Excel function. Hawks is not. So to find the percentile, you need to place the data in order from smallest to largest. That's common sense. We need it in numerical order. Then you're going to use this formula. It says let L equal N times P over 100, where N is the number of observations and L is the location of the percentile. If L is not an integer, you need to round up to the next greatest integer. So if you get back a number like 1.4, you're going to round it up to 2. If L is an integer, then you're going to average that location in the next location, okay? So check this out. Suppose that 40 members of your company are giving a screening test for a new position. These scores are reported in the table below. To inform potential employees of their screening test performance, you may wish to report various percentiles for the test score. They want you to find the 10th and 88th percentiles for the test. Now notice these numbers, I already gave them to you in numerical order. You don't have to put them in numerical order. So to find the 10th and 88th percentiles, here's what we're going to do. First of all, we need to figure out how many we have. How many members did they give the test? 40. They said we had 40 members. And to find the 10th percentile, we're going to substitute that into that formula that we already talked about. So we're going to say that L equals, then N represents the number of observations. So that's going to be 40 times, now the capital P is what percentile you're wanting to find. We want to find the 10th percentile, so it's going to be 10 over 100. Then all you need to do is put that into your calculator. All you need to do is put that into your calculator. What do we get? 4. Is 4 a decimal or an integer? It's an integer. Here's what that means. You need to take 4 and the next integer, which is 5. So you're going to take the 4th number in the list and add it to the 5th number in the list and divide it by 2. Okay? So 4 and 5 are not like numbers. That's not your answer. 4 is not your answer. They're saying the 10th percentile is your 4th term added to your 5th term divided by 2. So that being said, this is in numerical order. I need to find my 4th and 5th term. So 18 is my 1st term, 21 is my 2nd term, 3rd term, 4th term, 5th term. So that means I'm going to take 27 and 29, add them together, and divide by 2. And what do I get? 28. That means the 10th percentile for this test is 28. Okay? If you score 28, you are the 10th percentile. Now let's do the same thing, but now we're going to find it for the 88th percentile. So L equals 40, that's not changing, times, but instead of 10 over 100, we're finding the 88th percentile, so 88 over 100. So put that into your calculator. And what do we get? 35.2. Now, if you get a decimal out of your calculator, they tell you specifically round up to the nearest whole integer. So that's going to be 36. That means my 36th term is the 88th percentile. So we have 40 terms. We said 88th percentile of 40 terms is my 36th term. And so, yes, you can either sit here and you can count up 1, 2, 3, 4, 5, all the way to 36, or what's an easier way? Yeah, dude, we know this is 40, 39, 38, 37, 36, which means the score of 73 is the 88th percentile. Are you guys okay with that? All right. We have questions? Yes. So you know when you find the median and you have an odd amount of terms, you have to add the 2 middle terms together and divide by 2? This is the same concept. So when you have 40 terms and you're finding the 10th term, you have to add the 4th and 5th term together and divide by 2. Because that's saying everything below 28 is the bottom 10th percentile. Everything below 28 is the bottom 10th percentile. Good? Okay. Now, when you do Hawks, you have to do it by hand. You have to use this formula. You're going to have to use Excel to put it in numerical order, but you have to do it by hand after that. After today, you get to use Excel. I am okay with what Excel gives you because when you get into the business world, when you have to use Excel, they're going to accept this as well. Just remember that when you use Excel, yes, it is a completely different formula. It's just different, all right? So to find the Pth percentile on Excel, so P representing like 10th or 88th or whatever, you're going to type in equals percentile.inc, and then it says of your cell range and comma percentile is a decimal. Let's talk about that. When you type that in, percentile.inc, you're going to have 2 options. When you start typing in percentile, it's going to have .exc or .inc. That's exclusive or inclusive. We want the inclusive. You have to use the .inc. Okay? Then you're going to highlight your cell range just like normal, and then you're going to tell them what percentile you want. So if I wanted to do for the 10th percentile, you would type this in. You would highlight your cell range. So your cell range is that whole thing right here. Okay? And then your percentile would be 0.10 because it has to be a decimal. Are we okay with that? Cool. Moving on. Now, again, it is different on Excel. So you only use Excel after today. So let's talk about this example. It says, on the flip side, what if you were given a raw score and you were asked to find its corresponding percentile? So this would be more like you go to the doctor, you get weighed, and you're like, okay, I weigh this amount. What would that be as a percentile compared to everyone else around me? So to do that, you need to take the number of data values less than or equal to X, which is why that's going to answer your question of why did we average those two, because it has to be less than or equal to X. divided by the total number of values, and multiply it by 100. So, given the following data, find the percentile of a weight of 7.0 pounds. All right? So here we have the weights of newborn babies. Notice it is in numerical order. You're welcome. And we want the percentile of a weight of 7.0 pounds. So I need the number of data values less than or equal to x. So x is going to be my 7.0 pounds. Go ahead and count out how many are less than or equal to that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the question is, we have 2 here. So you're like, do I start with this guy or do I start with this guy, right? Now, we want less than or equal to x. We do have a data value right here that is less than or equal to it. So we have 2 that are equal to it, so we're going to start with this one, okay? So we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay? So to find the percentile, we're going to take 11 terms and divide it by how many we have total. How many do we have total? 20. And then we're just going to multiply it by 100. What do we get? 55. So here's what that means. You have to make sure your answer makes sense in terms of like what you're looking for. 55, it says what is the percentile of a weight of 7 pounds? That would mean it's the 55th percentile. On your test, okay, on your test, you need to make sure that you label that answer. The answer 55 means nothing to me. You need to tell me that that 7 pounds is the 55th percentile. Now, some people write it like this. That's okay. Some people write it like this, 55th percentile. I'm okay with either of those. All right? Now, on Excel, you're going to use this function right here, equals %rank.inc, and then the cell range, and then the raw score. The raw score would be what your x value is. So you want to find of this whole cell range, so the whole cell range, what is the percentile of 7.0 pounds? And it would come back 55th percentile. Actually, it wouldn't because it's Excel and it's different, but you get the gist. Are we okay with that? Let's go to the back side. Count both to 7. Now, the next thing we're going to talk about should be a really good review for you, all right? We're going to talk about box and whiskers plots. You learned about this in Algebra 1. You should have hit it again in Algebra 2. Box and whisker plots is a way to take your data and to split it into 4 equal sections, all right? Now, when you're finding a box and whisker plot, you're going to have to find the 5-number summary, okay? Now, the 5-number summary are 5 numbers describing the data, and they're like boundaries for our 4 sections, okay? The first number in our 5-number summary is the minimum, easiest one. Then the first quartile, the median, the third quartile, and the maximum. Minimum, median, and maximum are the easiest ones to find. You guys have been finding those since you were like yay big, okay? No big deal. You can also definitely find those on Excel. You know this would be equals min of your cell range. This would be equals max of your cell range, no big deal. This would be equals median of your cell range. We should be really familiar with those. The first quartile and the third quartile are also percentiles, okay? You guys know to find the first quartile, you're technically finding the median of the numbers to the left of the median, and the third quartile is you're finding the median of the numbers to the right of the actual median, but they're actually 25th percentile and 75th percentile of our data, okay? Now, to find it by hand, you have to do that for Hawk's Learning. To find it by hand, here's what we do. So, here we have create a 5-number summary for the ages of teachers in the math department at Big High School. I have all these numbers. The easiest one to find is my minimum. What's my minimum here? 25, so I'm just going to label it like that. What's my maximum? 54. We're going to label it like that. Siri wanted in on this conversation. Not today, girl. And then we need to find the median. Now, to do this by hand, you know you're literally just finding the middle term. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. That means the sixth term would be my middle term. What is it? 41, so we're just going to label it as median. Now, to find your first quartile, I know it's been a while, so I'm going to refresh your memory here. To find your first quartile, you're going to cover up the median and everything to the right of it. So notice I've covered up all of those numbers. I'm only looking at the numbers to the left of my median. Okay, so 25, 31, 39, 40. And I get this question a lot. Do we include the median? Never. Always cover it up. We never want the median in on this. Now, I want you to find the median term of these 5 points. What's the median term of these 5 points? 36. That's going to be my first quartile. Now, again, your first quartile is literally just your 25th percentile. That means 25% of the numbers are below it, 75% of the numbers are above it. Then, to find your third quartile, we are going to cover up the median and all the numbers to the left of it. Cover up the median and all the numbers to the left of it. Now we're going to find the median of the 5 numbers on the right. What's the median here? 49. That's your third quartile, otherwise known as your 75th percentile. 75% of the numbers are below it, and 25% of the numbers are above it. Okay? Now, finding it by hand, we should be really good at that. We really should. When it comes to Excel, which again, do not do this on Hawks today. You need to do it by hand. But in the future, when it comes to Excel, you can find the first and third quartiles 2 different ways. You can find it 2 different ways. The first way you can do it is you can do just like we learned on the front page by typing in percentile.inc, and you want to find the cell range, and then you would put the 25th percentile, so 0.25. That would absolutely work. But Excel also has an actual function for quartile. So if you're like on the test and you're like, shoot, I don't remember, blah, 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 you can also type in equals quartile, and it'll give you options. It'll say, what's your cell range, and then what quartile are you wanting to find? So the thing that you need to be careful of is when you type in quartile, it's going to give you options for 0, 1, 2, 3, 4, and 5. And you're like, what in the heck? We only handle first and third quartile. Okay, the second quartile is just another way of saying the median, all right? The 0th quartile is just another way of saying the minimum, all right? So those are the 2 different ways that you can find those. Now the next thing we need to find is we need to find the interquartile range, the interquartile range. Now, a lot of people get really confused about what this is. To avoid that confusion, let's talk about the actual word, interquartile range. What does the word range mean? What do you do if I ask you to find a range? Yeah, you always take the biggest minus the smallest. That's all it is. But they threw that word interquartile in there, interquartile. Now, you actually see the word quartile, so does that give you a hint that we're going to be working with a first and third quartile? And then it says inter. It just wants the range of all of the numbers in between my first and third quartile. That's all it is. So we're going to take my third quartile minus my first quartile, and what am I going to get? Yeah, 49 minus 36 equals 13. Now on Excel, there is not a function for that. There is not something that you can type in and it'll give you the interquartile range. You just have to find your third and your first and then subtract the 2. Finally, what we're going to talk about is the outliers. We're going to talk about the outliers. Now, outliers you guys should be aware of. If I were to give you a bunch of different numbers, for example, if I gave you the numbers 1, 2, 3, and 100, which one doesn't fit? 100 is way too big. That would be an outlier. Or if I were to give you 1, 101, 102, 103, which number doesn't fit? 1, it's way too small. This would be a high outlier. This would be a low outlier. Outliers are numbers that do not fit with the data, okay? But sometimes numbers in the data are not as easy to identify if they're an outlier unless you do some math. So here are the formulas for the upper and lower outliers. To figure out a lower outlier, you need to take the first quartile minus 1.5 times my interquartile range. So here, that would be, what's my first quartile? 36 minus 1.5 times my interquartile range, which we said was 13. So can you guys put that in your calculator quick? What is 36 minus 1.5 times 13? A little louder? 16.5. Now, I want you to think, sorry, it's in the way. I want you to think about what this problem is actually talking about. It says create a 5-number summary for the ages of teachers in the math department at Big High School. And they're saying any number lower than 16.5 would be an outlier. Well, doesn't that make sense? Like, could you have a math teacher that's younger than 16 and a half years old? No, that would definitely be an outlier. That wouldn't make any sense. Now, notice that it's any number below that. So if you have 16.5 in your data set, not an outlier. Okay, not an outlier. It's just below that. Are we okay? Then, for the upper outliers, it's the same concept, but we're taking the 3rd quartile now, which is 49, and we're adding 1.5 times my interquartile range. What's that going to be? 68.5. So they're saying any teacher older than 68.5 is an outlier. Well, doesn't that make sense? Have y'all ever had a teacher that's older than 68 and a half years old? I know Mr. Harris looks that old. He's really not. It's fine. But yeah, that would be an outlier. Okay, any number bigger than that would be an outlier. That's how we figure it out. Now, when you graph a box and whisker plot, it's going to look like this. Okay, check this out. The lowest dot is your minimum. The bigger dot is your maximum, but notice how this dot right here is not connected to the whisker. That means this is an outlier. This is an outlier. So this was my maximum, but it doesn't fit with the data, so this right here is my new maximum. What do you think 17 is? Your median, very good. What do you think 14 is? Your 1st quartile, and 20? Your 3rd quartile, very good. So all I want you to do is be able to read a box and whisker plot if it's given to you. So we just kind of figured that out. Now let's put this information over here. What's my minimum? 8. What's my 1st quartile? 14, median. 17, 3rd quartile. 20, maximum. 22. Now the interquartile range, do a little bit of math. 6, very good. 20 minus 14. Do I have any low outliers here? Do you see any on the graph? No. So what we're going to put is not applicable in A. And do I have any high outliers here? Yes. What is it? 30. All right. The next thing we're going to talk about is z-scores. Today we're going to talk about a z-score. A z-score transforms a data value into the number of standard deviations that the data value is from the mean. This is a standardization technique that allows us to describe the properties of data sets and to compare relative values from different data sets. Okay? Now some information about the mean. So here we have the z-score. To find the z-score, you're going to take the given data value minus, what does mu mean? What is that? That's the mean, and divide it by, what is that? The standard deviation. Very good. Now, just some facts about a z-score. If a z-score is negative, then the corresponding data value is less than the mean. It's below the mean. Pretty self-explanatory. If it's positive, the data value is greater than the mean. Okay? And then finally, this one's really important. A z-score is a unit-free measure. There is no label. There are no units. It can take a data problem from miles and a data problem from liters, and it can compare the two. That's what z-scores are for. So let's put it to use. Let's look at this example here. Suppose you scored an 86 on your human biology test and a 94 on your psychology test. Now, before we go any further, based on that information right there, which one do you feel you did better on? The psychology, because you're like, yeah, I got a higher score. Now the mean and standard deviations of your two tests are given below. What are the z-scores for the two tests? On which of the two tests did you perform relatively better? So check this out. For human biology, the class average was a 74%, and the standard deviation was 10. So in relation to what we did last class, like if I were to put this, and you don't have to do this, if I were to put this on like a bell curve here, the mean would be 74, so 68% of the class scored between a 64 and an 84. Do you guys remember that? 95% of the class scored between a 54 and a 94, and 99.7% of the class scored between a 44 and 104. Okay? That's what that means. In psychology, the class average was an 82 and the standard deviation was 11. So I have a question. Comparing these two means, which test do you think was harder? The human bio test, because the class average was lower. Now looking at the standard deviations, which test had a larger spread? Which test results were more spread out? The psychology, because it has a bigger standard deviation. So it says, what are the z-scores for the two tests? So the first thing I'm going to do is I'm going to find the z-score for the human biology test. Okay? Now to find the z-score, you're going to take your score. What was your score on the human bio test? 86. And you're going to subtract the class average, which was what? 74. Then you're going to divide it by the standard deviation, which was 10. Now, if you put this into your calculator or if you put it into Excel, either or, what do you need to put around the numerator? Parentheses, very good. Go ahead and calculate that. Tell me what we get. 1.2. Here's what that means. Okay, here's what that means. We had our bell curve here with a mean of 74, and this would be 84, 94, 104, okay, 64, 54, and 44. When you have a z-score of 1.2, does that mean you are above the class average or below the class average? Above, because it's positive. And it says how far you are away from the class average. This means you scored 1.2 standard deviations above the class average. So one standard deviation is 84. You scored above that. This would be 1.2. So you scored a z-score of 1.2, standard deviations above the mean. Are you guys okay with that? That's what a z-score does. Now, let's figure out the same thing for the psychology test. So the z-score is your score. What did you score on the psychology test? 94 minus the class average, which is divided by the standard deviation, which is, and what do you get? About 1 point what? 1.1. Should be about 1.1. Is that what we got? Yep, 1.09, about 1.1. Okay, so if I were to draw that bad boy out, we have the mean here, which is 82, and then a standard deviation, so 93, 104, 115, 71, 60, 49. You scored about 1.1 standard deviations above the mean. So here's one standard deviation. This would be about 1.1 standard deviations above the mean. Now, I understand that you got a higher grade on your psychology test than you did on your human bio test, but in relation to the class average and the class standard deviation, which test did you perform relatively better on? You performed relatively better on the human biology test because you scored 1.2 standard deviations above the mean instead of 1.1. Does that make sense? So let's write that out so you guys have something to refer back to. So you performed relatively better on the human bio test as you scored 1.2 standard deviations above the class average as opposed to psych, where you scored only 1.1 standard deviations above the mean. All right, that'll do it.